Welcome back to the channel. Today we are focusing on fluid mechanics, transmission of fluid. This is module number 3. After the introduction of hydrostatic, we know the principles of pressure, and as far as that is concerned, then today we're going to look at the transmission of fluid. In a hydrostatic, we learned that we are dealing with fluid that is at a stationary point. On this module, we are coming to learn about the fluid that it's in a kinetic motion. In this chapter, transmission of fluid pressure, it's about using fluid to do work in various machines. Some examples are hydraulic presses, hydraulic jacks. I can name a chair, an office chair. It has an hydraulic inside. Motor vehicle clashes, motor vehicle brakes, which our focus will be on brakes. Our focus will be on brakes, and will as well be on lifting machines. Will be on lifting machines. These are the two common two things which we are going to look at in particularly. Let's start with a simple brake system. I want to make a beautiful drawing for a brake here so that I can explain what is happening. Let's assume we are having a beautiful, let me use a pen. Let's assume we are having a beautiful pedal here. We're having a pedal which is connected to the, let's say here it's a hinge of the pedal, and from here it is a planer that has a piston like this. It's a beautiful piston like this, and we assume this is the cylinder. This is the cylinder. I will call it a master cylinder because I'm doing a brake. I'm trying to make a brake system, and I will name it like this. Then from here I can have a beautiful wheel. Let me draw it like this, and here let me draw a sleeve cylinder where it has something like this, Then I can from here draw a wheel like this one here. I'm just making a simple drawing so I can explain from it. And here we have our pipe coming to the sleeve. And I call this master what? Master cylinder. I call this what? A slave cylinder. Meaning this in particularly it's a drum. It's a drum, brake drum. It's a brake drum. This in particularly, it's a brake drum. And I will put shoes here. Let me put some shoes here. Let me put some shoes here. These are the braking shoes. Let me put another one on the side. Excuse my drawing. It means here I have two shoes, meaning when this is getting stretched, the shoes are getting attached to the circumference of a drum, and the wheel will be able to stop. Then remember here we have a pedal, and this is your car. When you're inside the car, you press the pedal here. When you press the pedal, the piston will move, meaning here it's what? It's oil, it's a brake fluid here, right? Then when the brake fluid is pressed on, it's gonna press and press, and the fluid will move throughout. And here at the slave cylinder we have two pistons. Remember, we always have two pistons in a slave cylinder, meaning this one will press this side, this one will press this side. As much this is concerned, when this cylinder is getting expanded, this it will press this to move to the shoes, and the brake will apply. So this is one of the the brake system we are going to deal with, and we're going to receive a lot of questions from this kind of a scenario. where you will be told about the master cylinder and you will also be told about the slave cylinder. Remember, if they are doing for a car, they're always going to give you 4 cylinders because each wheel has its own slave cylinder, but the master cylinder, it's one. That's why it's called the master cylinder. Sometimes they might give you 2 slaves, then they will tell you the slaves are 2, so you need to know that you are working on a 2 slaves. And let me give another example of transmission. This is how the fluid will be transmitted. Let me give another example of a hydraulic lifting. Suppose we are having a car here. Suppose you're having yourself a beautiful Range Rover here, something like this, and it is lifted here. It is lifted here, and here we have a ram. I will name it. Here we have a ram. It has a piston like this, and this is a cylinder. And our cylinder, it moves like this, like this, like this. And here is the oil, and here we have the planar side where we're going to receive our effort. It means this is here there's a piston, and this is the cylinder. Then I can safely name this cylinder 1, and I can safely name this cylinder 2, or you can name both 1, you can name other 2. The decision is yours. Okay, coming back to this, it means here losses. It means here we're going to have something like like a lever, and the lever will be connected to a pedal. Maybe let's say it's a pedal, and when we press here, this is going to be what our effort part, and this is going to be what our load part. So it means when we press the pedal here, the fluid inside here will be transmitted and will be able to lift our load. Which our load? It's our car here. So this is one of the things that we are going to talk about. So we're just going to talk about these 2 things only. First of all, because this is much easier to understand, let us first start here. I need you to be aware of something first, that when you have pressure at 1 and pressure at 2, your pressures will always be the same. This is one thing that you need to know. So we know that pressure 1 is equals to pressure 2. This is one thing we know for now. We know that the pressure that you exert here, if it's 100 kPa, you need to know that even here 100 kPa will apply. This is one thing we know about the pressure. Remember, Pascal says that pressure will be the same across all what? All surfaces. So this is what we're going to receive from pressure 1 and pressure 2. I hope we all can understand this. And from there, as much as we know, let us derive the formulas for a pressure. We know pressure is what? Is force per unit area, meaning we're going to have force 1 over area 1 equals to force 2 over area 2. So if we take it loose look here, we understand that what is the area? The area is this is a cylinder. Cylinders are in circle. So it means the area of here is going to be pi over 4d squared, and the area here is going to be pi over 4d squared. This is our areas, and you're going to come and substitute them here. So we make a conclusion that, all right, let us continue solving this, and we find a mechanical advantage. Let us get a mechanical advantage. To get a mechanical advantage, we need to break out our formulas. Let me get something. Quickly. Right. To get our mechanical advantage, we're always going to break out this. Let us divide this side let us cross multiply, meaning we're going to say force 1 multiplied by A1, it's force 1 A2, and it's going to be force 2 A1. We crossed multiplied, you see. So we're trying to find the mechanical advantage, right? And when we try to find mechanical advantage, is the ratio. In fact, it's the ratio between the forces and the ratio between the angles. So I mean the areas. So they must always be equal. Always they must be equal. Always they must be equal. So it means here, let us divide. You can divide with either, but I'm deciding that here, let me divide with F1. I divide with F1 and I divide with F1, right? And on this side, I divide with area 1, and I divide with area 1, and I divide with area 1. Meaning this side, F1 will simplify F1, then I'm left with what? Area 2 over A1. And this side, area 1 will take out A1, then I'm left with F2 and F1. So this is our first and most important equation, which this is the same as what? Mechanical advantage. So when we are always given mechanical advantage on the exam paper, we already know that F2 and F1, they're going to give us mechanical advantage. A2 and A1, they're always going to give us mechanical advantage. This is one thing we must always know, and it's very important and crucial information to feed yourself with. And I want us to take note of something. Let us go to the volumes. I want to be real quick. Let us go to the volumes. Suppose you are having a volume here, which I will say it's a V1, and you have a volume here, which is a V2. What I need you to understand is that the volumes will be the same as well. It means volume 1 will be the same as volume 2. This is always going to be the case. The volume here and the volume here will be the same. So what is going to be the difference? The difference is going to be the distance this piston moves and the area. So the difference is going to be what? Distance piston moves, and this is going to be the difference, right? Distance piston moves and what? Area of cylinder. These are the only two things that are going to be the difference, but rather than that, the volumes here and volume here will be the same. All right, if that is the case, then it means what I'm trying to say is that V1 equals to V2. This is what I'm trying to say. Let us derive the formula of V1. We know that V1 is what? Area times can I say, let's name it length. Area times length equals to area 1 times area 2 times length 2. What is this L? This L, if I press my F here on the effort, if I press my piston from point A to point B, so my length basically is from point A to point B. It means this is L1, and this one, it has to go from this point. Let me enlarge my cylinder. It means this one is going to move from this point A to point B, meaning, you see, the distance that the piston of the effort moves won't be the same with the distance that the piston of the load will move. Why? Because of the areas are not the same. That's one thing for sure. But our volumes will always be the same. So as far as we know this it's following the law of what? Conservation of what? Of energy. This follows the laws of conservation of energy. We know if what the law says about the conservation of energy cannot be what? Transferred or destroyed. Energy cannot be destroyed, but can be transferred from one object to another. If that is the case, it means energy at 1, work at 1 will be the same at work at 2. It means the work that's happening here will be the same as the work that is happening here. So what is work? What is work? We know work is what? Force multiplied by the distance. Then we know if we have work 1 here, we're going to have force 1 multiplied by let's say distance is length L1 equals to force 2 multiplied by L2. So I'm trying to show you that these two formulas, especially this one, is following the law of conservation of energy. And if they ask you to find the distance the load moved, you can either use the both. If you have area, you can use this. If you have force, you can still use this. So this are another formulas that are important to know. So we are at this point and we understand this. So from here, I need to let you know of something called pressure intensifier. Pressure intensifier. Pressure intensifier. What is a pressure intensifier? Pressure intensifier is a device used to convert low pressure over a large area to a high pressure over a small area. I will make a drawing and I explain my statement. It converts hydraulic power input at a low pressure into a reduced volume output at a higher pressure. Then this kind of intensifier, why do we need them? We need them so that we can get a high pressure at the system. Let me make a drawing to explain my pressure intensifier. Here we're going to have what? Pressure intensifier, right? I said it's a what? It's a device that comes from a large to a small. It means it's a reducer. When we continue with the study of fluid, we will see where we have sudden enlargement and sudden contraction. So this one is sudden contraction. It's part of sudden contraction, meaning it's something like this. You're gonna have your cylinder like this, and when you have a cylinder, it's going to be sudden contraction, and it means suddenly the diameter will change. And here you're going to have your beautiful piston, and here it will be like this. This will be a cylinder, meaning here there's fluid here there's fluid, and you're going to have area what? You're going to have area 1 and you're going to have area 2. So this is what we call pressure intensifier, meaning here the fluid, let's say at 1 fluid here was at what? It was at low pressure. It was at low pressure, but as much as we press the fluid here, it will go in at a very small area. It means now the pressure will do what? Will rise up. Then it means you're going to have a higher pressure. We've seen in so many cases where we have a low pressure system, but at the end of the day we need to convert it so that it can give us a high pressure system. Suppose you're having a hose pipe and you decide to close it at the opening there, and the fluid now gets out at a very small amount. It means our fluid will do what? Will run at a very high speed. So when we are going to consider, when we're going further with our studies, where we're going to consider the velocity of the fluid, you need to remember this, that as the smaller the area, the faster the fluid will go, depending where it comes from. So it means if here we have such a thing like that, we're going to have that high pressure. So this is one of the things, pressure intensifier, that you need to be aware of. You are going to be asked of this kind of a question. You just need to keep them in your mind and know what you are dealing with. These are the kind of a question you're going to receive. They're going to tell you about the pressure intensifier. They usually love to mix pressure intensifier with this kind of a drawing. For an example, here on the effort, they're going to install the pressure intensifier here. So it means you're going to have 3 areas: the area of intensifier, the area of that you're going to get here onto, and the area of the RAM over here, the area on the load. You're going to have this 3 kind of an areas. So familiarize yourself with something like this. And I quickly want to talk about something that is very crucial to fluid. Fluid does not need, especially brake system or lifting equipments, they don't need air. So when we talk about air, we're talking about one of the disadvantage of transmission of fluid. Air in the fluid contains, it causes bubbles, and the bubbles in the fluid are not really needed because our transmission is not going to be efficient anymore. So I need us to think about, just take a minute to think about the air in the fluid. What will happen when you have air in the fluid? In the brake system, for an example, your brakes won't be effective. you won't have effective braking system because of the the air inside the fluid. So I hope you know that air is not really okay. So now I need us to go and look at air in the transmission of fluid. I have something called a dissolved air. And a dissolved air is released at a low pressure, and it formed an intrinsic bubbles, like I've said, which markedly affect the properties of hydraulic circuit and are considered practical importance. Those who are doing hydraulic works, they will know that um, air causes moisture and it will cause rust in the system, so we need to release air always. So without any waste of time, let me go to the calculations of m. When we are going to calculate m, we'll be dealing with something called effective bulk modulus. This is what we're going to deal with. Effective bulk modulus is KE, something like this. This is one thing we're going to deal with. The formula, you will find them on your formula sheet. It's 1 over KE equals to 1 over K fluid. Sometimes they like to write liquid. I'll write fluid plus 1 over K cylinder plus volume air over, I'm going to explain all this, volume total plus multiply by km. All right, let's come to our formula. Usually we say, this is the statement that we say effective bulk modulus, it's slightly equals to the effective bulk of a fluid, modulus of fluid. They are slightly the same. That's why in most equations you will find they say 1 over Ke equals to 1 over K liquid. The reason they're saying this is because they are slightly equal, but under normal circumstances I need us to take it not as equal. Just gonna say 1 over K fluid plus 1 over K cylinder plus V air V total times K air. Let me explain. I've explained about this, and this is the modulus of a cylinder which you'll be given. Usually you are given. If you're not given, you go into calculate it. How are you calculating this? It means K cylinder equals to your modulus divided by constant. I will say constant. Why is it constant? This constant is 2.5 less. It's 2.5 less usually, less stated otherwise. This ratio, we call it, it's a ratio of Bayesian ratio. Those who are doing strength of material and 6, they will know about thick cylinders, where we have to calculate the lateral strain divided by the longitudinal strain, where it's going to give us what? It's going to give us a Bayesian ratio. So this 2.5, it's a V equals to lateral strain divided by longitudinal strain. So we need to keep this in mind. This is just something, it's a food for thought. That's where we get this constant. So it's usually 2.5 or less, but you're always going to be given unless stated otherwise. So this is how you're going to get your K cylinder. This E, your modulus of elasticity, you'll be given. It will be according to the you see, it's for cylinder, the type of a cylinder that is made of. Some cylinders are mild steels, some cylinders are stainless, some cylinders they are plastic. So they're always going to give you the elasticity of what kind of a cylinder you are given. So don't worry about this, you'll always be given of it. And immediately we go to the volume part. You see here at volume M, here we usually give it as percentage. We always give this air as percentage. If you are given 2%, if they say there is a 2% of air in the system, then you know you're going to substitute here by 2. And how are we deriving all these matters? If you check here, we have 2, it's in percentage, and we have V total. this is going to be 100%, meaning we basically converting our 2 to 100%. This is what we're basically doing. But when we're going to substitute, if they give you 2%, it means here you're gonna put 2%, and here on V total you're gonna put 100%. Let me look one example and show you what I'm talking about. All right, nice one. Let's look at something here. Look at number 2. Let's look at number 2. The number 2 says that 2% of air by volume is present. It means this 2%, you're going to substitute here on V air, you're just going to put 2. Then here on V total, you're going to put what? 100. Right? So one person once asked me a question like, say, what if we are given no percentage? What if we are given a position where there is no percentage? Let me as well look at something for you that does not have a percentage. I saw it somewhere. Okay, fantastic. This I think it will be one of the examples that we're going to do together. That one, just keep in mind, is one of the things that we are going to do together. All right, and you're gonna solve this together when we are not given a percentage, right? But it's not something troubling. It's something very interesting and fun to study. And let us look at the Ka. This Ka as well, it has its own formula where we're going to say Ka equals to the gamma A, which this gamma it's 1.4. We know according to the adiabatic law, multiplied by pressure that is exerted on this pressure it's a force over area, which you'll never forget that. It is the pressure that is exerted on the cylinder. They will give us the force and they will give us the area of the cylinder. Then as much we're given the force and the area, we can find the pressure. So these are the most important thing to note and to know. And you don't want to calculate your effective bulk modulus. This is question number 1 for bulk modulus that you can use. If you don't want to use this equation, you can use this equation number 2, where we say effective bulk modular equals to what? Pressure is equals to pressure multiplied by volume divided by change in volume. This is how you can calculate your effective bulk modulus if you don't want to use this formula. But the two formulas, they will always complement one another. And the pressure is always going to be this one. So what about this volume? This volume, it is the volume of the cylinder, which is going to be area multiplied by the length of the cylinder. They're going to tell you the distance of your length, how long it's your cylinder. And we come here. Where is this change in volume? This is where something called free play comes in place. Something we call it free play. What is a free play? Free play, the word itself explain on it explains itself that I am a free play. Free play is an effective movement when we have bubbles in the system. There's going to be a free play. It means oil will move freely. It will want to fill the space. That is, oil of course causes vacuum, and we don't need vacuum in the system. So because of the vacuum, the oil will play itself around the bubbles to play. So that is the free play. So it's important always to calculate the free play. So this change in volume, it is the original volume we divided by the change. It means it's a new volume. How are we calculating this? We're calculating this by saying this is going to be what? This is going to be area multiplied by changing length. What is this changing length? Just changing length, it's a free play. So this changing length, it's a free play. It means this is the original length. Now this is the length of the piston, how fast, how it moves. It's a stroke length in a way. So this is the same. Now we have bubbles. It means our length will be affected in a way. So this is our free play. This is how we're going to calculate what? Our free play. So I'm done and I'm dusted with transmission of fluid. And what is left now is to go with you through examples and we solve them together. All right. What need to be done? What need to be done? It's just a simple example together, and we are okay. All right. I'm going to do this example like I promised. I'm gonna do this one. You can example 3.12. You can make a screenshot. Make a screenshot. Okay, fantastic. Suppose we are having that information that you made screenshot from. They are telling us this: a hydraulic jack has a ram of 60 with a planer diameter of 20. The planer is operated by a lever. It means we have a hydraulic ram. It means we have something like this, something that we've drawn it. It's something like this. They say it has a lever, and here is our load. They say a hydraulic jack has a ram diameter of 60, so it means the diameter here is 60, right? The diameter here is 60 with a planer diameter, and we have a planer diameter this side, which is 20. The planer is operated by a lever which has a mechanical of 4, so they give us mechanical advantage of 4. They say this is controlled by a lever is like this. The operating pressure of jack is 6 MPa. They give us pressure. They told us the pressure is what? 6 MPa. This is the pressure they gave us, and they said the planer has a stroke length of 30 mm. The planer here, but in the stroke length, so we are given the length here, which is what? 30 mm. The fluid in the system has an isothermal bulk modulus of 1.8. So they give us K fluid, or you can name it K liquid. It's 1.8 GPa. You see, they give us K fluid. Then number 1, they're requiring us to do what? They calculate the mass that the jack can lift. So they need the mass of what? Of the jack. They need us to calculate the mass of the jack. How are we going to get the mass? The mass is inside what? It's inside pressure. We know that if we have pressure equals to force over area. If we find force, we're going to what? To get the mass, because we know that force is what? It's mass multiplied by gravity. This is what we know. So let's substitute. This is going to be 6 times 10 to the power 6 equals to force over area. It's pi over 4, and our D is going to be what? 0.06. You agree with me? Our A is going to be hola. Our A is going to be 0.06. So let's put our A, it's 0.06 squared. Then our force here is going to be let's find the force. Our force it's 16,965. This is our force. Newton. Then we automatically say force equals to what? mg. Then we divide by what? By g. We divide by g. Then our mass equals to, we say this by 16,965 by what? 9,81. Then our mass is giving me 1729,3 kg. So this is our mass. So we're gonna get the mass that this is going to carry it with. So we got this mass. And number 2, they say number two says that calculate the effort that the operator must apply to lift the mass. So they need what? The effort. It means effort is here. Remember, from our loads, and load is here. So load is equals to effort. We always know this, that load equals to what? Effort. We always know that a load equals to what? Effort. So if our load equals to effort, it means our what? Our force equals to area. Force equals to area. We know this, right? So which, because load and effort, they are pressure. It's pressure 1 and pressure 2. Remember we said this, the pressure here will be the same as the pressure here. So how are we going to derive this? It means we need the force of what? Effort. So I can name it Fe. It means force of effort, we need this force. So we're gonna multiply this with what? With this. Then it means force effort equals to Fa. This is for load, right? Is this multiplied by A? Then we're going to say this force, we found this force because it's this one. The force is this one, 16965. Remember, it's 16965. You remember this, right? Then we divide it by the area is pi 4 multiplied by the area 0.06 squared, multiply by pi over 4 times, this is the area of what? Of this one over here. So it's gonna be 0.02 squared. Then my effort is going to be, how much is our effort? Our effort is going to be 47124. This is our effort. This is how we're going to get what? Our effort. So this is our effort. Then we know we need the effort of this to lift this with this mass of this force. Makes sense, right? And number three, they say the number of stroke that the planer must make to lift the mass of 3 millimeter. It means they said we must find what? The number of strokes. How many strokes do we need here? 1. So that the load can be lifted. You know, when we are lifting on a jack, we don't just do and the jack goes up. We do multiple of times before our load is exerted to the required amount. So here they say the number of strokes that the planer must make to lift the mass of 300. So it means we need the length. Remember I told you that they gave us on number 3, they gave us the length, which is 300 millimeter. So this is the length, right? And I told you that volume 1 is equal to volume 2. Then if volume 1 is equal to volume 2, area 1 multiplied by length 1 equals to area 2 multiplied by length 2. So what we want here, we want the length of a ram. We want a length of a ram because they gave us 300 as the length of what? Of a planer over here, right? So we know that this is going to be pi over 4 multiplied by 0.06 squared, and L1 we know it's 0.3 equals to pi over 4 multiplied by 0.02 squared multiplied by L2. So we're going to solve for L2. So this will simplify this, then we divide this, then we get the we get the 0.02 squared multiplied by 0.03 into 0.06. No, I've made a mistake here. The diameter here, I put the diameter of a load, so it is supposed to be 0.2 and 0.6 comes this side because we need L2 for this. Let me just correct it. 6. Then I found my length as this is supposed to be 0.03. I found my length as 3.33. Then remember we are given 300. We are given 300. We should remember that. Remember here they gave us a length of 30. You remember here they said the stroke length here is 30. That's why it's 0.03, right? Then that's why I got 0.33 millimeter, right? But remember we are given 300 as what? As a millimeter. Then we have to divide this from this. Then we're going to say 300 divided by 3.33. Then we're going to get the number of stroke. Then we're going to get the number of stroke divided by 3.33. Then our number of stroke is 90.1. So this is the number of stroke that is needed. So we need 90 strokes to lift that. Interesting name. We need 90 stroke, 94 stroke. So this is our number 4. Okay. Suppose we are having here on number 4, what do they want? Let us see. They say calculate the free play on a RAM. So they need changing L. Remember, they need changing L. So from our notes, we know A is our changing L. From the notes we made, they're basically looking for this. This is what they're looking for. So they're looking for a free play. So they say calculate what? Calculate free play on a RAM if the volume fluid it's, so they give us a volume of a fluid. Volume fluid it's 8.482 times 10 to the power minus 4 meter cubed. They say take the bulk modulus of cylinder. So they give us KE cylinder as what? 6.5 GPa. This is what they gave us. And yes, so they want us to calculate that. All right, where do we start? We know that we need to find KE. That's one thing we know, because the main formula is KE equals to pressure and equals to what? KE equals to pressure, and it's changing. KE equals to pressure is equals to what? Multiply by volume, divide by changing volume, right? This is our main priority. But we don't have KE, but we have pressure. So we can come to that formula where we say 1 over KE equals to 1 over K fluid and multiply by 1 over cylinder, and we can find our KE, and we say 1 over KE equals to 1 over K fluid. Do we have K fluid? Yes, we are given here as 1.8. Remember, so it's 1.8 times what? 10 to the power 9 plus, not multiply, plus 1 over cylinder. Do we have cylinder? Yes, we're given here 6.5 times 10 to the power 9. Then we can do what? We can solve for KE. If the easiest way to solve this, the easiest way to punch this, just say open brackets, and you should put inverse of 1. You put everything here, you say 1, it divide by 1.8 times 10 to the power 9 plus 1 over 6.5 times 10 to the power 9. Then put everything to the inverse of, then close the bracket. Sorry, what am I doing? Then close everything and put the inverse. Close everything and put the inverse of 1. It's gonna give you 1.064 GPa. Yes. Then this is your KE. Then you can substitute it here. Let's come this side. I don't have space there. Let's come this side. Then our KE equals to pressure volume over changing volume. So let's make changing volume subject of the formula. Then you're gonna have 1.064 multiplied by 10 to the power 9 equals to pressure. What is our pressure? Remember our pressure we're given, they say 6 times 10 to the power 6. This is our pressure multiplied by volume. Where do we take the volume? At this point we are not given a percentage. I told you if you had the percentage you put percentage, but now we are given this, so it means we're going to have what, 8.4 times 8.482 times 10 to the power minus 4 divided by changing this. Then let's find this. So I'm going to divide this with this first, right? Then I'm going to say, let me reset my calculator. I'm going to say 1,064 times 10 to the power 9 divided by 6 times 10 to the power 6. Then it's giving me 177.33 equals to 8.482 times 10 to the power minus 4. Changing this, then I take this side and I take this side, then this is like this, then divide this one with this one, and it's 8.482 times 10 to the power minus 4 divided by answer. It's giving me 4.78 times 10 to the power minus 6. Then I'm not done. I know that this one is what is the same as area multiplied by changing L. It means it's free play. Then it means I know this is what, area multiplied by free play. So I need free play, right? And I say free play equals to changing volume over area, whereby changing volume is this, is 4.78 times 10 to the power minus 6. Then I come to my area, I say pi over 4 times what is our area? 0.06, remember, 0.06 squared, because it's happening here. Then our free play equals to what, 4.78 times 10 to the power minus 6 into shift pi over 4 and multiplied by 0.06 squared. My free play is 1.69 2 millimeter. This is my free play. So my free play is that. Okay, so this is how we are solving a free play. Thank you very much for watching, and thank you very much. I hope you understood this kind of a question. They're always gonna come, and they're not really difficult. Just go through most of the exam papers and see how they ask in them. So thank you. Remember, you will either be asked about this and the pressure intensifier. It's either this one, pressure intensifier, or they're gonna ask you about a brake system. So these are the questions they're always gonna ask you. Thank you very much. Cheers.